Okay, for part A, they want a free body diagram showing all the forces acting on the car. Hey Mr. Wong, the free body diagram I'm about to draw in the video is not a correct free body diagram because the arrows need to be touching the mass and there should be no components. The one I drew right now is the correct free body diagram, and the one I'm referencing in the video is just for the sake of visualization for future problems. Thank you. So this is A. Here's my car. I know that there's going to be a weight that's exerted from the car because mass times gravity, and gravity always exists in, these realistic scenarios. So then mass times gravity, it's going to have a weight. But in reaction to that weight, there's going to be an Fn. And this Fn I'm going to draw larger because I know that this Fn has components because my axis looks like this, where this is x and this is y. Because my Fn has components, right? I drew my Fn larger because I know that this Fmy component is going to cancel out with this Fg to maintain vertical balance, while this Fnx component is going to contribute to the centripetal motion. And because this Fnx component is what's contributing to the centripetal motion, right, that means I know there's going to be an acceleration that goes inwards because centripetal motion. And the reason I don't draw acceleration upwards or downwards is because this Fmy cancels with this Fg. So this AC is what goes forwards, which is centripetal acceleration, and there's this Fnx that causes that. Okay, now let's go to B. B, they want me to derive an expression for Fm, right? Well, first off, let's look at this diagram. I know that this Fn is going to be a reaction force to this Fg, and this Fmy, which cancels out the Fg, I'm going to draw here to form a triangle, which is easier for my calculations. And then I know there's a Fnx going outwards into the center to rotate. Okay. And then let's establish the angles. I know as per alternate interior angles, this angle up here is equal to my given angle. I know that the angle formed here is going to be equivalent if I were to draw, like, let's say a parallel line to, reference that this angle right here is going to be equivalent to that angle in there, right? And since those two angles add up to form 90 degrees, I know I can say that this angle is the same as my given angle. And that's the information I need to get started on this problem. Okay, well, first off, I know that Fn is going to be equal to the square root of Fnx squared plus Fmy squared, because of Pythagorean theorem. Well, first off, since it has components, let's actually get them into components. Let's try to find what Fnx and Fmy are equal to. And they're acting on different planes, so I'm going to draw this awesome tape, like this awesome column chart. Okay, let's look at the x direction. So I know that the forces in the x direction are what contribute to the centripetal motion because according to my plane, my x-axis and my y-axis, my x-axis resides on the plane that is inwards to the center. So therefore, the sum forces of Fx will be equal to mv squared over r, the distance from the rotation, the motion, right, to the center. So the distance from the line of motion of rotation to the center. This distance right here. But I don't have that. What I do have is h. So I know that tangent theta, with the theta being right here, is going to be equal to my opposite, which is what I want, which I will call r, over h, right? So I know that this r, which is the distance from the rotational motion to the center, is going to be equal to tangent theta times h, or h tan theta. So instead of writing r, I will write h tan theta. Right? And then sigma fx is just going to be the forces acting inwards, which is Fnx. And that's the only force acting inwards. Is equal to mv squared over r, which is now h tan theta. Now for the y direction, you need the sum forces of the y direction, sigma fy. And that's going to be whatever's acting. Well, I know it's going to equal to 0, actually, first of all, because it's not going to be flying, right? So what is sigma fy? Well, I know there's a fmy acting upwards, but that cancels out by an fg. So taking the upward direction as positive, I'm going to do fmy minus fg. It says fg is the downwards direction. That minus, showcases that. It's going to be equal to 0. So I know that now fmy is equal to fg. And I know what fg is, m times g. With this, I can plug both values into this expression I have at the start. Because Pythagorean theorem. The two legs, and then that's the hypotenuse, Fn. So this Fnx is going to be replaced with this awesome expression. And this Fmy is going to be replaced with mg. Right? It's going to be squared. It's going to be squared. So that's my expression for Fn. Now let's go part C. Part C, they want an expression for a centripetal force in terms of the given quantity and any fundamental constants, blah blah. Well, as I established earlier, my x-plane is the plane that acts inwards on the block, right? So I already know that my FC is going to be equal to my Fnx. Right? But what did I establish my Fnx to be? mv squared over h tan theta. So an expression for my FC would be just simply mv squared over h tan theta. For part D, they want me to derive an expression for v in terms of any given fundamental constants possible, as appropriate, blah blah. Any given quantities and fundamental constants, right? Well, to find v, I will start with this. mv squared equals h tan theta, right? I mean, mv squared over h tan theta is equal to fc, right? Well, I also know that fc is fnx. Here we go. Well, what is fnx? I mean, my bad. Fnx, right? Well, what's Fn equal to? Well, I have this, right? Fmy. And according to my diagram, Fmy is opposite to the angle. So that means Fn sine theta is equal to mg. Right? I know that Fnx is going to be adjacent to my angle, so this is Fn cos theta. Is equal to this. Right? Well, using this, I know that Fn is equal to mg sine theta over sine theta, mg over sine theta. Right? Because I have mg over sine theta, I can plug that in instead of Fn. Right? Cosine over sine is cotangent, so I have mg cotan. Theta is equal to mv squared over h tan theta. Divide m by both sides to cancel those out. Right? Multiply h tan theta to the other side. Square root both sides. And I get expression for v is equal to the square root of g cotan theta times h tan theta. And it looks similar to what we learned about how it's like gr tan theta or gr cotan theta. So because it's similar to that, I can infer that this solution is probably right. Let's go to E. Well, between E, I know that now there is friction, and the coefficient of static friction is so that the car does not slip. Now I want Vmax. Well, first off, because I want Vmax, I know that this is the maximum speed it can go before the car probably hits a curve or something, because the Vmax is going to make it want to go up, up, up because of the inertia. So then I know that Fs will be acting downwards. So first off, let's get that free body diagram I had earlier. This will be very helpful as reference. I already established that this data created between the Fnx down here is going to be equal to the given angle. So I'm just going to call it that. And this AC is not needed. in terms of this problem, what I'm using it for. Let's recall this fnx. Excuse me. fmy. I'm just going to move it to the other side to form a triangle that I can use for easier reference. And this fmy over here, I'm going to take it out. And there we go. Since I established that the friction force is going to go downwards to prevent the inertia from making the car hit the wall or something, if it's like, let's say, a freeway situation, because I know this inertia is trying to go upwards, so, you know, that's just inertia. I don't even have to look at it. I just know that Fs goes downwards in this scenario. Right? Because I established that this angle right here is the given angle, I know that this 90 degrees created like this angle is not the given angle, but I know that since there's going to be, oh wait, no, here. Let's draw the components for Fs first. So I know there's going to be an Fsx going inwards, because, you know, my plane is that, x and y. So I know there's an Fxx going inwards. And then 1 going downwards, Fsy. Fsy going downwards, and the Fsx going inwards. Okay. And this Fnx refers to the black line. Because this data is the one that's like given, right? I know that this data right here is not going to be the same as the one given because this 90-degree angle is formed, so this data has to be the other one. So, but because I know that there's a 90-degree angle down here, formed right here, right? I know that this data formed down here is the same as the one that's given. So those are my angles for my reference points. And now let's split it into columns. There's going to be an x direction and the y direction. Okay. Remember, the forces in my x direction are what influence my centripetal motion. R now, because that's what the problem dictates, in terms of R. And then I know that the sum of the forces in my y direction are going to equal 0 because I'm not flying. So, let's get this started. Well, what forces are acting in my x direction? This, boom. So, I'm just going to add them up. Fnx plus Fsx is equal to mv squared over r. And now what forces are acting on my y direction? Fmy, Fg, and Fsy. So Fmy, taking my upward direction to be positive, minus Fg. I'm counting the downward direction by minus Fsy. Is equal to 0. 0. Great, now let's turn it into trig. We know that the Fnx is going to be cosine because it's adjacent. Fnx is adjacent to the angle. Fsx is opposite to the angle, so that's going to be sine. Equal to mv squared over r. Fmy, I established, it's going to be opposite to the angle. Fsy, I established, is going to be adjacent to the angle. Fsy is adjacent to the angle. Therefore, it's cosine. Is equal to 0. Okay? Now, how am I going to link these problems? I'm going to connect them by Fn, right? Well, first, I need to establish what Fn is equal to. Well, since the problem wants the Vmax formula in terms of µs, right? I'm going to first move Fg to the other side because Fg has nothing to do with my Fn. It does not turn into Fn or something. But then I know that Fs is going to break into µs times Fn, so I'm going to get µs times Fn plus theta. It's going to be equal to Fg. Because, you know, Fs is µs times Fn. Now I'm going to factor out Fn. It's going to be sine theta minus µs cos theta is equal to Fg, which I will change to mg. And if I divide both sides by this, I get the expression that Fn is equal to mg over this. So that's one link done. And that's how I'm going to connect these two expressions, by setting them equal to Fn. Okay, so now here, I'm going to change this to mu s Fn again. It's going to be equal to my mv squared over r. I know that this stays the same, Fn cos. Plus that, right? Factor out Fn. It's going to be equal to mv squared over r. Right? And then if I divide both sides by this, right, I divide it by that, but I take the reciprocal, which is going to be 1 over this, and multiply it, because I'm dividing. So I can take the reciprocal and multiply. So I have Fn is equal to this. Right? And now, since I have two Fn's, I can link the two equations together, setting them equal to each other. Because both of them are Fn, and I'm just saying a true statement. Fn's equal to Fn. So I see m on both sides, right? That means if I divide both sides by m, I can cancel them out. So immediately, I'll start with that. I'll multiply this to bring it over. Multiply both sides to get this. Multiply both sides by the bottom denominator to get that. And now I have b squared is equal to this. Square root both sides to get rid of the squared. Right? And since I classify my friction as going downwards to counteract inertia, I know this is Vmax. So there's my Vmax equation. Now let's go to F. Okay, for F. They want Vmin now, right? So I will use this diagram reference for that. Well, except now I know my Fs is not going to be going downwards. My Fs is going to be, my Fs is going to be going upwards. And the reason it's going upwards is to, it's going upwards to help the, because the, okay, now part F. Boom, this diagram's back. But now, my static friction is not going downwards to keep the car from going too fast. It's going upwards to keep the car from falling off because it's going so fucking slow. Okay? So this is Fs. Fs is going to have two damn components, Fsx and Fsy. You can think of it like those Vietnamese grandmas, right? They can't drive on freeways. So, Fsx and Fs... No! Not Fx! Fsy. Now, let's make snowflakes. Happy angle right there. Bad angle, stupid angle, fucking angle. Kill yourself. There, right? Now, with this right here, you're gonna know that, this 90 degrees, that means happy angle is here. But that means stupid fucking angle is here. And because stupid angle is there, happy angle is up here. Okay? You get it? They add to 90 degrees, triangle needs to be 180 degrees. Fucking purple bad angle, red is happy angle, red is angle they give you. Good angle. X. Y. Two planes. Vroom, two planes. You know what else is two planes? I'm not going to specify on that comment. X and Y. Okie dokie. Now, sum of the forces in the X direction. It's going to equal the centripetal motion because my X plane is what's pointing inwards or outwards, okay? mb squared over r. Delta sigma fx. It's going to be the inwards force, Fnx, minus the outwards force, Fsx. Great, that's all there is. That's all there is. Equal to that, right? I ran out of space. I'm going to move my y. Down here. Sigma FY. We're not astronauts. We're not flying. We're on the ground. Equals 0. Where are the forces acting in my y direction? Here. Boom. Boom. Kaboom. It's gonna be FMY. It's gonna have help. Plus FSY. Because your grandma, Vietnamese grandma, minus FG is equal to 0. Let's move FG to the other side by adding FG to both sides. Great? Great. I like that. Okay. Trig. Adjacent. FNX is adjacent. Fn cos theta. Adjacent to the angle. FSX. FSX is opposite to the angle. Correct? All this, move it over here, is equal to mv squared over r. Right? Now, here, FMY. FMY is opposite. FSY is adjacent to the angle. Therefore, cos theta is equal to mg, because mg is equal to fg. If you don't know that, then why are you my teacher? I'm sorry, I love you. Now, fs is mu s times fn. Good boy. Fs down here is mu s times fn. Mu s is so ugly. Right? Cos theta equals mg. Fn cos theta minus is equal to mv squared over r. Ooh. No! Sine theta! Good? Good boy. Now, factor out Fn. Why? I'm gonna fucking link the two equations together with it! It's gonna be okay. Factor it out here too. Right? Now, isolate for Fn. Divide both sides by this giant monster. Boom. Fn is equal to mg over this. This monster I just divided both sides by. Isolate for Fn. Divide both sides by this giant monster. Right? But because I divide it, I can take reciprocal, which is multiply by that, right? So, this is divided here. Let's move that back. It's divided here, but I can take reciprocal, which is 1 multiplied by that, which is 1 over this. So it goes into the denominator with r. Okay? Fn is there. Fn is equal to that. Fn is equal to that. Now I use linking. Kaboomy! Kaboomy! They're equal to each other. Why? Because Fn is equal to Fn. M on both sides. I can divide by M by both sides. They're canceling out. Right? Isolate for V squared. Multiply both sides by this monster. G goes here. Multiply both sides by what I'm dragging around. Boom. Now, isolate for V. Square root both sides. Happy? And then this boy right here. Your name is V min. Why? Because I established friction's going upwards because you're a Vietnamese grandma driver. There you go. This is V min's equation. Happy? Happy. Jesus Christ. Let's go to G. Alright. Part G. Prove that the net force is given by this function. Plus, minus. Well, I only have so many choices here. Vmax has a plus and minus. Vmin has a minus and plus. Seems like this is the more appealing choice. And I doubt it would be Vmin or anything near Vmin, because then that would be a pretty stupid car. Like, I don't think everybody's an Asian grandma driver on a freeway. Anyways, FNet. Well, FNet. No. Just let me draw FNet. I mean FNet. Net force. They're synonymous. What is that equal to? Well, I mean, I know that FG is going to cancel out with one of the FSYs or FMY, whatever, right? Well, in this case, it's going to cancel out with FMY, and then FS is going to have to pull it downwards, help pull it downwards. Okay? So I know that the centripetal motion is the only thing that's left, because the verticals cancel out. Yes, delta F y is equal to 0, right? So the forces acting inwards and outwards on the x-plane, that is happy, right? This exists. So this is why I can safely say the net force is mass times centripetal acceleration, Mach, which is equal to mv squared over big R. Right? Well, what's V? Here, the stupid equation I'm using, Vmax. Kaboom! Here comes the gun. Oh look, V's gone. Over R. This cannot be the way. But it is the way. Squared cancels out the square root. Square root is gone. Do. R. It comes up. You know why? Because I can flip it. Here. This is what I mean. When I divide by this, right? It's the same as multiplying by the reciprocal. That's why I'm taking it to the bottom. So R goes here. R cancels out. Now I'm left with mg times this monkey. Well, as I look at here, I see mg, it wants to be left out, right? So I'm going to put it up here, so I can look at this easier. Well, what does it want? It wants cotangents, right? So if I look at this, what is cotangent equal to? Cosine over sine. So what am I going to do? Multiply top and bottom by 1 over sine. Why? Because that's literally freaking multiplying it by 1. It's equivalent. So if I multiply everything by here by like 1 over sine, right? This is over sine, and this is over sine. Ooh, this is over sine, and this is over sine now, right? And God forbid I forget the datas. That's bad. So here are the datas, Mr. Lewang. Here are the datas. I'm trying my hardest to get the kids to do the freaking assignments. I'm giving so many announcements. I don't know what more I can do, but anyways. Cosine, okay? Now let's simplify. Good. Remember, the mg is still there. I just left it up there to ease your eyes and my eyes. What can you see with those eyes? And I can't forget the US. Right? And then mg, it comes back. Here. Boom. Kaboom! Magic. Okay. Right, FNet, right? And FNet, is it equal to that? Cotangent theta plus mu s. 1 minus mu s cotangent theta times mg. Yes, it is. I'm done.